Alright, hello everybody and welcome back. So here we do fire and health, right? Or we don't. Okay. Fire, extremely important for the development of humankind, right? Broad scale, human history, biggest developments overall, technologically, yeah, pretty big, alright? In fact, through all of human history, sources of energy and weapons tend to be the most important technological developments. You can basically trace the whole thing with those two. And this one is kind of both, right? So ideas of when human beings started using fire are complicated. It was at least 400,000 years ago, but it's kind of hard to rule out the possibility that maybe it was even older than that, as much as millions of years, or was even used by Homo erectus and some of the things that are not technically Homo sapiens like we are as species, some of those early ancestors of modern human beings. No fire kind of means that, you know, none of this stuff happens, right? We don't get to be here and online talking to each other. It provides a lot of things, right? So it provides heat, allows people to migrate into areas that might be really cold, especially too cold at night. Provides light so that people can continue working on things into the evening. Gives them a lot more so they are no longer completely constrained by daylight hours. Gives them protection from predators, right, who would most likely be warded off by such a thing. And it also gives them ways to get better tools, right? So essentially by heating things up and then working on them or hitting them, you can do a lot more to shape them. You can shape them with a much better edge or blade, which would have been critical to developing some of these early tools. Awesome. So the nutritional aspect of this kind of can't be overstated, how big of a difference it is between cooking all the food and cooking nothing, right? Eating everything raw. We talked about matter and energy, right? Human beings and all living things are these open systems, constantly exchanging matter and energy with our environment. Constantly. Does not stop. Should not stop. There are a lot of advantages in terms of matter and energy for fire, right? So it essentially allows human beings to pull a lot more nutrients and calories out of things, right? So now that we're getting energy from the fire, this reaction that we set off, right, you don't have to work as hard, is what it essentially comes down to. And this influences the whole course of human development. Everything from your teeth to your stomach to social structures is impacted by this change, right? To cooking things, right? Get more calories, you have more energy available to do things like think and develop your brain and lie to other people, which are all really important and adaptive things. Sorry, not sorry. This is big. Nutritionally, this completely changes the stomach of all humanity forever. Awesome. Fire is also something that can be extremely harmful, right? Wildfire as a disaster. So we have human beings trying to control it. We have all the ways that it has influenced us over time, right? And then we've adapted to it. But at the same time, it can be too much, right? It can have all these effects. I've kind of given away the answer here, right? But maybe we could do a mental image, right? You imagine a fire starting out on the side of the hill. Does it tend to move up the hill or down the hill? It tends to move up, right? Why? Well, heat rises is the simple way to put it, right? And a lot of the air and other stuff is going to be blowing what direction? Is it going to blow here and then come back down the hill? No. It's going to blow here and blow all the products up the hill, right? So fire tends to travel uphill. It spreads uphill really easily. It likes hills and topography, broadly speaking. When I say topography, I mean, you know, elevation. Hills, valleys, right? Mountains, terrain, right? And all the different changes you can have there is what I mean by topography is an essential element for this. The more hills and valleys you get, essentially, the more that fire is going to spread, broadly speaking. There are three elements that kind of all have to meet together. So before we talked about the fire triangle for the fire itself and its reaction. Here we're talking about fire as a hazard to human beings, right? So for this thing to be a hazard to human beings, it doesn't just need those three things, right? Those are the three things required for the fire itself, but to be hazardous to people, you gotta have these three. So you have to have some sort of point of ignition, right, to light a fire. You have to have a pathway that that fire can spread through, and there isn't always a pathway. So it's extremely common to have things like, you know, parking lots that fire cannot cross. Although, in the case of something like that, you have to watch out for extremely windy conditions where sparks can be carried from tree to tree. Might be an important detail to remember for the lab. Okay, awesome. And then you have places that are exposed, right, vulnerable. So essentially, it doesn't matter if a fire starts or where it spreads if there's nothing vulnerable, right? If there's nothing that's vulnerable or exposed or could be harmed by the fire. If you have all these things in common, you have point of ignition, you have a pathway to a vulnerable area, that's when we get loss of life or property or fire as a true disaster. Unlike a lot of other natural disasters, the damage done by this one really depends on environmental factors, right? So by contrast, right, something like an earthquake happens, it doesn't matter if it's windy, it doesn't matter if it's 100 outside versus 60, earthquake is going to have the effects that it has, right? It's just not sensitive to those conditions, but fire really is, all right? It's important to get these down, right? Wind is, right, going to make the fire burn much more unpredictably, much more intense than it would otherwise. Moisture. So water has a much higher heat capacity than something like air, right? We talked about this idea of thermal conductivity compared to heat capacity, right? How much heat something can hold on to. So essentially, if you have a lot of moisture, right, and the fire comes through, it takes a lot more energy out of the fire to proceed, right, to heat the stuff up, right? On the other hand, if everything is really dry, then without that water there, it doesn't take as much heat or energy to light everything on fire. And that is part of why, you know, if you put a wet log on a fire, that fire's not going to burn very well compared to dry stuff, right? Temperatures, higher temperatures means we're going to get worse fires, the reverse, broadly speaking. Topography, right? Hills and valleys, more of these means we get more fire spreading uphill, makes things more unpredictable in some ways, despite how constant this part of it is. Not good. Fire is made worse by climate change. So there is drought, and we'll talk about drought as a major factor. Higher temperatures in general tend to make these things worse. You have more evaporation, which leads to drier conditions, which leads to worse fires. As a result of this, and other changes as well, like drought, which are made worse by climate change, but you couldn't necessarily say that it is all caused by climate change. Problem is a lot worse now than it used to be. These wildfires burning out of control, burning huge regions of the US, was not always quite the problem that it is today. It's worse by a factor of 2 from 40 years ago. And it's also, and I'm going to spare the details on this, but it's something that is thought that it could get worse dramatically. Why? There's this idea of a tipping point. You make conditions a little bit worse, right? These conditions, if they're just a little bit worse, it seems like there could be a lot more fires, kind of pushing things over the edge of its limits. That's all we're going to say on fire and climate change for now. Fire and air pollution, right? Makes it worse, puts out a lot of smoke. I did want to show, right, so broadly speaking, more smoke, right, so smoke density increases from left to right here. The more smoke density you have in a given area, the more risk that you have of heart issues, right, especially acute heart issues or emergency room visits, and respiratory issues and distress, both. Ultimately, right, we're trying to be critical here. These trends are pretty messy, right, and these error bars are really, really big, but the overall trend is extremely clear, even if there might be exceptions in some of these categories. So yeah, wildfire smoke is especially bad, even in the wide world of smoke. Has small particles that tend to infiltrate into the lungs, get into the bloodstream, and it also has all these other things in it, right? Particulate matter, but also carbon monoxide, other things that you don't want to breathe in. It has a mix of all sorts of nasty things, not just one kind of smoke, right? Firefighting in the US. So long history of this one starts around 1750, especially up in the Northeast, areas which are more densely populated. I want to say Philadelphia, I might put it in a note. At first, these tend to be volunteer, become professionalized over time. But as cities get bigger and bigger, this stops working. And there's a number of major fires that influence development along the way. The first organized fire departments started to come about 100 years later in major cities, right? These continue to get bigger, more organized, more professional over time. And today, the job is much more complicated than it would have been back then. Why? You have complicated synthetic materials and compounds, human-made stuff and products and synthetic chemicals and things all over the place, which can greatly complicate fire and those pollutants, the different kinds of things that can be in the smoke. Modern day firefighters have to climb tall buildings and mess with that. They also have to do a lot more things other than just fight fires, right? So I have this figure here that there's about 1 million fire calls per year annually, right? So that is the number of like emergency calls or 911 calls to all the fire departments in all of the United States per year, but the number of calls that they get for other things is higher by a factor of like 2 to 10 times higher. A lot higher. And here's a cool fire engine from the 19th century. Okay. Case studies. We got 2 of them. This one, very recent. I want to talk about the wildfires in Maui a little bit, right? So, Hawaii, broadly speaking, is a place where it clouds up and rains like every day. In fact, it tends to be extremely regular. Like, parts of the islands will cloud up and rain at the same time for the same amount every day, like clockwork. If you've ever been there, right? Everything is sunny and fine. It gets cloudy, it rains, and then all the clouds go away every day. As a fun fact, people there don't use the weather app, broadly speaking, because they don't need to. They don't really care because the weather is the same 24/7, 365. They might talk about waves or anything like that. Disgusting. I'm so jealous. Anyway, Hawaii can have drought like anywhere else. So drought is not just about the dryness, it's also about how dry a place is compared to its usual conditions, right? And as it turns out, climate change has this way of making things drier, broadly speaking, through a lot of regions because of increased temperature and evaporation, leads to drought even in places like Hawaii. So I know the text here is a little bit small, right? So white means no drought, and this is the same time as our fire, right? As our big wildfires we may have heard of. White means no drought, yellow means a little bit of drought, right? And then all the other colors mean worse drought. This is complicated by factors, right? So wind, the fact that it's a drought, and also invasive species which have made it to the island of Hawaii. This one is also a factor for our fires in Arizona and creating fire pathways and underbrush that wouldn't have been there before because we have new invasive vegetation that comes in and changes everything about the ecology. Damages here are extreme. So billions of dollars, have thousands of buildings. I want to say something like 2,200 buildings collapse, something like 100 people lose their lives. And this, not good. I've included this in part just to kind of illustrate that fires can happen anywhere. Even though they tend to happen in certain places, they can happen anywhere. This Texas wildfire of 2024, of like February 29th, 2024. This one is evolving. In fact, I think I have news from like 11 hours ago on this that is already outdated. I believe this has already made it to the largest in Texas history. Something like 1 million+ acres burned. Now, this would not be the all-time record setter in a place like California, but for Texas, it's pretty bad. This is up in the panhandle of Texas. If you're not sure what to picture here, it's like fields of corn. It's basically like Kansas. No trees, extremely flat fields of corn and wheat as far as the eye can see, and subject to extreme weather, both snow and, in this case, fire. In fact, I think there was like, for this fire, like fire, and then it snowed on top of the remains of the fire. Not good. This one is still a developing story, but massively impactful, and can lead to other fires in other areas as well. So that is all we're going to talk about as far as fire as a hazard to human beings. Next, we talk about fire specifically in Arizona and what that looks like.